So if you have been watching this series from the beginning, I believe you could see that it is possible to do a meta-regression or meta-analysis in R. So congratulations for reaching to this um, point, step number 13. That's awesome. So if you have any questions and you want me to create more content for R, please feel free to leave them in the comment section. I can tell you that questions really pay off in this channel, and they help me to create more content for R. Yeah, so let's go there and look at meta-regression analysis. So what's meta-regression? It's basically we create a model that has, instead of like regression analysis, which looks at the effect of one variable, just one variable, we might say, hey, if these variables come together, if we put them together, they might have an effect or they might not have an effect. So we want to know which model. So model will have like 2 or 3 or as much as your data have to look at. So for me in my study, I do have 3 moderators, so I could create like a model for 2 or a model of 3 as much as I want, and I would say which one would have an effect on the data. So basically the same process, and I would say this one is model, same process as model, the same process as regression analysis, but with more moderators, as you can see. So just quick reference, you see here that's just one. I'm just going to be adding more for regression analysis. Same thing, and I would say, hey, let's see a model that has 2, say feedback type, and to add another variable to the model, I will click just the plus, only plus, and I would say I want to know if language proficiency and feedback together could have a result, and I would say summary, because this is regression. This will tell R I'm looking for something. It's a regression analysis. So I have model 1 has 2, so that's why we call it multiple regression or meta-regression. If we have more than, if it's more than one moderator or a factor or a variable in the analysis, then it's called meta-regression. So we have a model for 2, and let me look, and just a quick with this analysis, you just go down and look at the p-value, and the p-value on the right, as you can see, what it says, hey, this model together, they don't have an effect, so it's not statistically significant when we look at other data. Same. So the p-value is very crucial, and you could look at adjusted R-square and others if it's significant, but we put these, no, they cannot explain, they don't have an effect. Let's say we have another one, I want to put it with feedback, publication type, the same here, it's not significant. Yeah, so for this study, it doesn't seem that there is any one that's statistically significant, and they don't have an effect on the study results. So basically, whatever model you're gonna put, let's say language proficiency, you can create as much models as you want and see the results. no p-value still. Yeah, this is how you could do that. In your study, the results I believe would be different. You might have few statistical significance with some moderators when you put them together. But in my study, it's not so. I believe the case for you is going to be different because you will have, by default, you have a different data set. So with every data set, the results are expected to be different. So yeah, so thank you for watching this series, and if you have any questions, you want to learn more in R, subscribe and leave your questions or your comment in the comment section below. Thank you for watching and see you in another tutorial.